Okay, so good morning, everyone. We're gonna have Professor Mark talking to us today. Professor Mark is professor from, I'm gonna do that in Portuguese, okay, Professor?
Sure, sure.
É o professor titular da cadeira de Engenharia e Gerenciamento da Construção. Ele é professor da Universidade de Purdue. Ele atua há mais de 33 anos como professor e pesquisador. Tem colaborado com a indústria na área de engenharia e gerenciamento de construção, especialmente em melhoria de processos, redução de risco de desastres, gerenciamento de infraestrutura, controle de custos, tomada de decisão de gerenciamento de projetos, gerenciamento de risco, planejamento estratégico. Ele é engenheiro credenciado para atuar como profissional de curso certificado, também especialista em seguro de risco e construção. Trabalhou em inúmeros projetos estaduais, municipais, pelo Construction Institute, Industry Institute, tem mais de 50 palestras como keynote speaker, autor de mais de 200 publicações, 3 livros muito utilizados sobre planejamento, engenharia e economia. Ele é o presidente do Council for Research and Innovation in Building Construction, o CIB, é assessor técnico do Downstream and Chemical Committee, do CII, também é consultor acadêmico do Department of Building and Real Estate do Hong Kong Polytechnic University e presidente do Conselho Consultivo do Global Leadership Forum for Construction Engineering and Management programa da Universidade de Purdue. Então, a gente está muito bem acompanhado hoje. So, Professor, thank you so much for your presence here today. We are making a record from this speak. And I don't know if Vanderlei want to say anything else or if we can start.
No, I'm good. Mark, thank you very much for accepting our invitation. It is an honor to have you here. I know that you are very busy, so go ahead, please. The floor is yours.
Okay, thank you. Thank you very much for that kind introduction. Let me see if I can share my screen. Do you see my screen?
Yes.
Yeah, it's coming. Perfect.
So you see my full screen? Okay, perfect. Well, good morning, everybody. And indeed, thank you very much for inviting me today to share some of my work with you. What I thought I'll do is, I'll share with you some of the results that we got from one of our recent research. We did that for the Construction Industry Institute, and I'll talk a little bit more about CII just in a bit. But what I wanted to do was share a couple of things with you. One is innovation in the process of modularization. That's some of the theories that we have proposed, and also talk about the results of one of our research projects, which led to a people, process, and technology roadmap for offsite modular construction. So with that said, the first thing I always like to ask is that in an audience such as this is, how many of you know where Purdue University is? And I often get, a few hands go up, and I see that, okay, people have been there. So that's wonderful. And what I'll do is I'll show you where we come from, where I come from. So this is, of course, United States, and we are located in a city called West Lafayette. As you can see, it is close. It's in the state of Indiana, and we are not too far from Chicago. So it's about 120 miles south from Chicago, where the city of West Lafayette is located. It's a university town, and the population in West Lafayette is about 55,000 when the students are present. And we have Lafayette, which is a sister city separated by the river Wabash, and that has about 150,000 students. It's a beautiful campus. As you can see, every American campus, you will find that there is a clock tower and there is a fountain. So these are our clock tower and fountain, as I show you here. And the fellow sitting over there, he's Neil Armstrong. Neil Armstrong is one of our alumni. So the building behind that is the Neil Armstrong Building for Engineering and Administration. And what you see on the right-hand side is a mall that goes from Fountain to different parts of the university. As you probably know, Purdue is well known for engineering, and we have 13 schools and divisions. I fortunately represent 2 of those, civil engineering and construction engineering and management. And I have a research lab that I started about 23 years ago called SPARK, stands for Solutions for Profitability and Assessment of Risk in Construction. And we do a lot of different things, primarily 5 bucket areas, as I call them. Infrastructure management. We look at how to renovate infrastructure, capital rehabilitation planning, investments, and so on. We do a lot of work in disaster risk reduction, as in the influence of natural hazards, and if they lead to disasters, then what is the role of infrastructure, and how we can determine capacities, and how we can figure out construction methods that would allow us to rebuild the damages that were caused by some of these disasters. We also do a lot of work in profitability and strategic planning in terms of what is the ability of a firm to generate profit, not profit from a particular project, but more so profit from the firm itself. So we try to identify, what are the sick processes, what are the sick units within your organization, so that corrective action could be taken that would help you improve the profitability of your company. Then we also do a lot of work in risk in international construction. If your company is wanting to expand overseas, what is the risk involved at the macro level or the country level? What is the risk involved at the market level? And what is the risk involved, of course, at the project level? And how can one determine what that risk is, and how to appease the different parties that might be involved. Then my 5th bucket I call as my contemporary area. So anything that is interesting, exciting, we go into that. If it becomes a bucket itself, then of course we pursue that further. Otherwise, we wrap it up and move along. And within that, we've done a lot of work in the housing industry, intelligent planning units. I'll be talking more about that today, a little bit later. Composite applications in construction, construction analytics, interaction analysis. A lot of these research, mostly in the housing industry, intelligent planning units, composite applications, leads to more modular construction. So we have dealt with that quite extensively over the past years. As you can see, a number of benefits have come out of this research. But today, this is just showing, primarily all the areas that I've worked in. But today, I would like to share with you some of the results we have in terms of people, process, and technology roadmap for offsite modular construction, and a theory that we introduced a few years back called as the theory of intelligent planning units, which I believe would be the next stage of modular construction, and something that we can all think about. Talking about CII, that's perhaps many of you already know, but CII stands for the Construction Industry Institute. It is based out of UT Austin, University of Texas at Austin, and it was started in 1984 by some of the faculty, got together with the industry, and the idea was to do research for the industry and identify what are some of the issues that the construction industry might be facing, and how can we resolve that. So there's industry partners, there's of course academia and the government, and they identify research needs, research topics, and then as academics we bid on those projects, and if successful, then you engage in at least a 2-year project with about 20 different companies on your team. So you can see that CII over the past years has done a lot of work in modularization and workforce studies. As you can see, in almost 30 years, they have produced results, factors influencing advantage, disadvantage of offsite construction, We have learned from potential shipbuilding industry techniques and how those could be incorporated in the construction industry, modeling the composition of 2030 workforce, how that is likely to show up. And the one that I'm going to talk about is the most recent, which is the impact of offsite construction on the 2030 workforce. So with that said, you might say, well, what was the motivation? Now, we all know that when we went through the pandemic, actually this research we were doing was during the pandemic, that we were all facing a shortage of skilled labor. In fact, during pandemic in the US, many of the skilled labor just simply walked away from the industry. So we are facing that shortage even now. Suboptimal project outcomes, something that we face all the time. Poor productivity in the construction industry. As you know, construction industry productivity is one of the poorest among the different industries, where manufacturing industry productivity has gone up significantly, but not so much in the construction industry. Inadequate leverage of technologies. Our industry is known to be behind in adopting technologies, and that is indeed a problem that could be solved and resolved through modular construction. And of course, all the uncertainties that we face at the job site. The good part is that the size of the global offsite modular construction market has a very positive trajectory, as you can see, where the compound annual growth rate is almost 10%. So that is indeed excellent, and looks like, you know, from the positive trajectory, you can see that that trend is likely to continue. And I'll talk about some of the reasons that we found why that trend is also important for us in the industry. As I mentioned, we started this research shortly before the pandemic, and then we were meeting as a team. I had about 18 or 20 different companies represented on the team, and we had to meet off, online like we are doing now, and try to complete this research project. But the question that we wanted to ask was, is the pandemic a threat or a promise for offsite construction? And as you can see, you know, there was overwhelming response to indicate that events suggest the pandemic is only going to support offsite construction. There's a high chance that COVID-19 will accelerate and be a catalyst for people adopting the offsite approach faster. You know, so some of these comments, as you can see. Then you might say, well, what is the value proposition? And how can we present this value proposition to those who are still thinking about whether modular construction or non-modular construction? As you can see, of course, it allows increased competitiveness, allows better workforce planning and management. It's a very controlled environment in which we can operate, improved identification of shortcomings and the needed capabilities, allows for a framework for continuous improvement and risk reduction given the modular setup and the factory setup, and I'll talk more about that a little bit later. And of course, the ability to assess, benchmark, and track progress given the nature of the modular industry. You know, so we are talking to different companies, different owners, and different contractors that have used modular construction. And as you can see, their vision for 2030 for offsite construction. And again, it was overwhelming response that in the future, because of all the issues that I mentioned earlier, including a workforce, skilled workforce requirement for offsite construction, improved productivity, that we will see more and more of offsite construction as we move from 2020 to 2030. So indeed, a very positive indication for this segment of the industry, construction industry. So in conducting the research, we went through a lot of the typical steps that we would expect, and that included literature review, of course, what has been done. I mentioned about CII having done a lot of research over the past 30 years. We did a survey of all the experts in the industry. About 100 responses were received from companies of different sizes, vendors, owners, contractors, suppliers, and manufacturers, of course. Then we did also semi-structured interviews of a select group of professionals. We did case studies on top of that for application of modular construction. And in the end, we came up with what we call as a maturity model and a scoring tool that what is the strength of off-site modular construction as far as your company is concerned, and how you can identify how mature your company is in adopting some of these practices. The result of which was, as you can imagine, a roadmap. And instead of just talking about people, as the title might indicate, we also looked at process and technology, because all three of those elements need to go hand in hand. And we came up with the roadmap that would indicate what would be the workforce requirements, what type of process implementations we will have to think about, and what type of technology would be needed and is currently available. So starting with people then, let me point out the top 3 workforce occupations in the highest need for training in offsite construction. And you can see that we identified 5 different categories. Those are design and engineering, construction and management, administrative, on-site craft, and then off-site fabrication. As you all know that we need to have a good strength off-site as well as on-site to make modular construction, off-site construction most effective. So as the next 3 columns you'll see are indicating the top 3 workforce occupation in that particular category. So design and engineering, for instance, BIM, 3D, 4D modeling, QA/QC, planning engineers, in construction and management, construction managers, of course, constructability specialists, field interface personnel, on-site craft, for instance, required off-site module installation personnel, lifting cranes and rigging personnel, instrumentation, and so on. And as well as, of course, off-site, where we need more computer-aided manufacturing professionals, assembly, fabrication, and then planners and those who can expedite the process. And clearly, at the present, at least in the US, if we are looking at site built, and even if we look at 1 or 2 modules on site, that does not require quite as much training as would be required if much of the construction is going to be off-site. In that case, we need to come up with different skill levels. And so here are some key off-site construction skills that we identified that will need to be incorporated in the training process. So under 3 categories, design and engineering, construction and fabrication, and then administrative skill sets required. You can see that under design and engineering, we identified fabrication, packaging, stability and constructability of components and modules, supply chain issues, procurement, logistics, the very offsite construction philosophy. How do you implement offsite construction right from the concept stage, and then what would be the logistics and the supply chain requirements to actually make that feasible? So that would, of course, include design freeze, offsite typologies, and so on. In terms of construction and fabrication, more implementation of automation, robotics, computer-aided technologies, placement, assembly, installation requirements and different techniques, transportation, of course, the fabrication process, whereas under administrative requirements would be manufacturing and factory knowledge, skill set that perhaps we don't have as much when we talk about interface with the construction industry. So in addition to this skill set, there were some advantages. I think with offsite construction, there's more opportunity for workforce diversity. And as you can see, there's these are present numbers, but you can definitely see improvement in engagement and diversity in the workforce that might be feasible with offsite construction, where we can provide a more controlled environment for the workforce and different skill sets can be attracted to the industry. So there's a lot of potential in terms of improving the skill sets and the demographics of the construction industry. Then, so what are the opportunities for offsite construction? As you can see, better health and safety, greater productivity, enhanced working conditions, reduced fatigue, smaller crew size, less rework, and so on. So I know that you all are engaged in modular construction, so many of those things might, of course, you are familiar with you. But let me talk about process. In terms of process, the improvements that we found, future growth in offsite construction process from 2020 to 2030, and 2030 is not too far from now, just a few years away. But 87% of the practitioners expect increase in offsite construction. There will be 21% average increase in offsite construction, and about 7% average increase in fully automated offsite construction activities. So definitely much more emphasis on offsite modular construction is likely to be seen by the time we hit 2030. You might also know that, by 2030, we are expecting that about 41% of the workforce, construction workforce in the United States. And with pandemic already influencing availability of skilled workforce, and by 2030, if we're going to lose 41% of the workforce on top of that, that is a serious consideration that, at least in the United States, we need to be thinking about in terms of what changes we need to implement so that we can take more advantage of modular and offsite construction. So what are the different characteristics? In 2020, we focus more on single trade, prefabrication, customized components, permanent structures, single skill labor, high skill labor. But by 2030, it's likely to be more modularization, standardized components, portable, relocatable structures, multi-skilled labor force, and high-skilled labor force. So clearly, the training requirements, if we now think from an academic perspective and from a training workforce perspective, we will have to think about how we can train these individuals so that it becomes seamless. As modules are created in the factory environment or offsite environment, and as they come to the work site, that we almost have a plug and play type of a design that it becomes seamless in terms of constructability and making facilities feasible. So, there are a lot of lessons to be learned. There are certain lessons, and of course, there are pain points as well. And the lessons learned, of course, are, we get an experienced integrated offsite team. That is a requirement. Adapt and work within the offsite framework. So our philosophy needs to be a complete offsite construction thought process. We need to provide basic training for the workforce. Of course, reward and incentive mechanisms for offsite workforce as well. But some of the pain points would be, currently at least, immature processes, inconsistent implementation of offsite construction. If the offsite philosophy in a particular organization is not robust, then they're likely to still be thinking on-site construction and wanting to implement a few modular components. And that defeats the objective of moving construction offsite. So lack of detailed offsite design solutions, of course, late offsite construction decisions that might delay the lead time, might delay the supply chain process, and so on. So clearly, the benefits are plenty, and you all know those very well. So in terms of workforce, 50 to 60% of stick-built can be moved to offsite construction. Labor costs can be reduced. We might expect improved productivity because of the factory environment. We can reduce safety incidents. Quality could be improved as well. Less disruption, and perhaps more saving in time also. So in terms of technology, we found that the key trends in technology is currently used offsite, as in, this was around 2020, 21 that we were looking at. So, these are some of the technologies that are being currently used in different levels, of course. BIM, automation, robotics, digital twins, modular formwork, integrated modules, mass production, and so on. But what we found also is that by 2030, the technologies that we are likely to see more would be remote monitoring, use of smart sensors, use of artificial intelligence interface, extended reality, integrated real-time management information systems, and a few more. So the question that comes to mind is that, is our industry ready? We went through Industry 4.0 or Construction 4.0, but there's also Industry 5.0. So how is that to be integrated when we're thinking in terms of modular construction moving towards 2030? So what we did was we came up with a maturity model and a scoring tool to sort of assess that where do we stand at the present in terms of modular offsite construction. And I'll quickly share with you, what this maturity model is. There are 5 levels. Initial level, 6 months to 1 year into implementation of modular or offsite construction. Repeatability, define, manage, optimizing. So these are the different 5 levels as a company would go through, implementation of offsite philosophy, modular philosophy within their thought process. And indeed, looking from 3 perspectives, as I pointed out, so people, process, and technology, and how mature our organization is in terms of implementing some of the offsite philosophies. So in terms of meaning of each of these maturity levels, the initial level is organization has its offsite construction development disorganized, and as you move further up in the scale, so level 5, for instance, then would be the organization realizes the full offsite potential and constantly looks for improvement. So that's the range in which we have designed this maturity model. If you look at some of the attributes, again, under the 5 maturity levels of initial, repeatable, define, manage, and optimizing, you'll see what are the expectations from people, process, and technology as you move up the maturity level. So from the initial level to optimizing level. So for instance, in terms of people, initially you would require training, provide soft skills, technical skills to your workforce. But as you start maturing, you might have regional centers of excellence within your organization that is already looking at the next steps in modular thought process and how to improve your own profitability in that sense. In terms of process, again, starting with the initial level, work with companies that understand and enable offsite construction. You're still in a learning process, but as you mature, you might have R&D centers or programs for offsite construction within your organization or as a consortium of organizations. Same thing with technology, recognize need to adopt the offsite philosophy versus innovation-centric approach to technologies, where you're now not only implementing advanced technologies, but you're also thinking ahead of how we can make the most use of the upcoming technology and research to improve our profitability in our companies. Just to give you an idea, there are multiple inputs are required from the user. I know that the font probably is too small to read each detail, but what we're looking for is different weights to people, process, technology within your organization that you want to provide input about status of the different practices, as you can see listed there. This is just a partial listing here, and then the score of from 1 to 5. From 1 to 3 using the drop-down menu that you can scale. Where does your company stand with respect to these practices? There are 5 outputs that we get from the model in terms of score for people, score for process, there's a score for technology as the 3 important things. And the score is from 0 to 15. So the 5 stages, 3 points per stage, sort of. And then it also gives 2 additional outputs. One is an overall score of where does your company stand in terms of maturity model. So here, for instance, the score indicates 7.9 indicates moderate maturity of your organization in terms of adopting offsite modular philosophy. And it also gives you, in terms of percentage, of how many practices you have successfully implemented within your organization. So sort of gives you a gauge of what more do you need to do and how you can go about improving the adoption of that philosophy within your organization. So clearly there is a call for action. 2030, as I mentioned, is not too far away. So clearly we need to take advantage of the growth benefits that I mentioned. The CAGR is about 10%, and that is indeed an opportunity for all of us. Follow the roadmap to improve project outcomes. There are certainly guidelines that are coming from the industry participants. And of course, we don't want to stand still and fall behind. Construction, as I mentioned before, we are known for late adoption of technology and low productivity. So as compared to manufacturing, of course, that here is an opportunity, I believe, that we all need to adopt and move forward. A little bit about the report that I mentioned. This is the CII report RT 371. And you can see that there are 12 different elements that are covered in that report. It's quite extensive in terms of documenting where the industry stands and what are some of the results that I just shared with you. And if you like, please approach CII to get your own copy and so on. I mentioned that this work was done within a team environment, and you can see that these are the various companies that were involved. My co-PI, I had 2 co-PIs, Islam Al-Adawi from Missouri University of Science and Technology, and also Kim Lascola-Needy. She was from University of Arkansas. And then we had Ryan Assad, who's now at Rutgers, as also on the team. And we had representation from the State Department, from consulting firms, from construction, from vendors such as Oracle, Bechtel, Victaulic as a vendor again, and many others. The idea was to engage all of these representatives to understand where do we stand as an industry and where do we need to go in terms of offsite construction, modular construction, and then workforce development. But having said that, I also mentioned just a few minutes ago that so far we have reached maybe construction 4.0 or industry 4.0. But as you all know, that we recently industry 5.0 was introduced, which has a slightly different focus. The focus is now more human-centric, promotes talent, diversity, empowerment, so resilience of the industry, and then of course sustainable aspects. You also are aware of the UN Sustainable Development Goals, many of which out of the 17 SDGs, I think about 8 or 9 of them relate very well to our industry as well. So I believe that offsite modular construction has a lot of role to play in achieving many of these objectives. We talked about implementation of technologies. Now we need to take it one step further in terms of focus. Instead of focus on connecting machines, we would be focusing on delivering a customer experience. Instead of mass customization, we'll have to be thinking about hyper customization. And instead of intelligent supply chain, we'll have to think about responsive and distributed supply chain. Instead of implementing smart products, we'll have to think about interactive products. Same thing with manpower, distance from factories. Of course, as I mentioned, we'll have to return of manpower to the factories, and how that can be implemented more in terms of a human-centric, resilient, and sustainable construction industry. There are many agencies and many research institutes that are working in these areas for sure. As was introduced, I'm the current president of CIB. It's a global organization, and many of you are also members of that organization. And as you know, within CIB, there are 40 different expert commissions and task groups that are looking at various aspects of the construction industry and what needs to be done in terms of research and development. We are going to hold the World Building Congress 2025 on my campus here at Purdue University. And many of these results will get shared with everybody. So you are, of course, all of you are welcome. I'll be sending out information to Professor John and others to distribute, and I'm sure you will have that. But this CIB as an organization is spread over 53 different countries, and multiple researchers working in different areas. So you get a sense of what is happening in global research in terms of the 40 different commissions. I've just highlighted a few that were relevant for today's discussion. Customized industrial construction, intelligent and responsive buildings, off-site construction, smart sustainable building environments, zero carbon buildings, smart cities, and so on, that I believe reflect well in terms of a modular and off-site construction. And as I pointed out, there's a group of global researchers that are engaged in these different 40 commissions, trying to understand, what needs to be done to take the industry, our industry, to the next level. We have been talking about Construction Industry Institute. CII has introduced 17 different best practices. And as you can see, one of them clearly is planning for modularization and how that can be implemented within our organization. And initially, when CII introduced modularization, that was more off-site module manufacturing and the transportation of those huge modules on barges and getting the site prepared in inclement weather conditions and how those modules could be placed. But with the recent research that I shared with you, there's now the emphasis is all across the industry in terms of adopting the philosophy of off-site modular construction and how that is going to implement the nature of training required, the workforce requirement, and of course, the implementation of that. So, we are also engaged in research in that area. And I want to share with you a theory that we have proposed a few years back. Actually, it was published in 2017 about what we call as theory of intelligent planning units. And what do we mean by that? So let me walk you through a little bit about what do we mean by intelligent planning units and how that is going to transform our industry in terms of modular thinking, in terms of off-site thinking. So as you all know, the dynamic nature of our business, makes it very difficult to establish a streamlined flow in the construction process. It makes it difficult to optimize the required resources in terms of labor, material, equipment, and so on. Meeting the client expectation in terms of cost, quality, safety, etc., becomes often difficult. We always say that each project is different, so we start thinking from scratch. And but there, of course, from a modular perspective, there are synergies that could be adopted from project to project. So there is clearly a need for reducing this complexity in some ways. It will be great if we can centralize the valuable information from existing projects and look at some of the repeatability concepts, providing best practices in the planning process for making better decisions, and then of course incorporating intelligence in the built environment. So the way it started was, the question is, we started to ask a question, how can we enable the complex built environment systems to be more intelligent? What do we need to do to reduce the complexity in our business in the construction industry? So we started this research almost 15, 20 years ago. And the question that we were asking was that, we're looking at nanotechnology. Now, you know that nano is a billionth of a part. And we said, well, in our business, we look at, big projects. We look at mega projects. So when you say nano, what does that mean for us? And if I were to ask you that question, you might perhaps say that, well, a billionth of a part might be perhaps a brick. So if brick is that nanoparticle for us in the construction industry, then the next question is, how can we make that brick more intelligent? What are the avenues available to make that unit more intelligent? And the answer could be perhaps now manufacturing, composite bricks, perhaps, that implement nanotechnology and perhaps process optimization to at the unit level, that then could be replicated throughout the organization. Now, you might say, well, what does that really mean? So let me explain that further. So if you were to take that brick and if you were to implement sensors using now the nanotechnology and implement that brick strategically, let's say 4 or 5 units of those bricks in a room wherever you are sitting, then that room itself would be capable of identifying whether it is humidity, temperature control, sound, air quality, whatever those sensors are used for. Now, certainly that room is now an intelligent planning unit. And if you were to have, let's say you are sitting in your office and in your building, let's say there are 20 such offices. Now, by optimizing one unit in terms of all the KPIs that you want, or the key performance indicators, you are preparing a unit now which could be replicated n number of times. So you can see that by implementing strategic brick as a unit in a wall or in a room, now you certainly have an intelligent room, which then could be expanded to a building to a campus to a city to as far as you want to take it. So that is the concept in short about what do we mean by intelligent planning unit. Same thing can be done in terms of process also, and I'll take some examples a little bit later to explain what I mean by that. So IPUs are a well-defined unit that can be replicated and implemented at different levels of complexity in rooms, buildings, cities, and so on. As you can see at the bottom, there's a similarity in terms of how our body as a human body functions with different cells that come together. They are cells that are repeated, and each cell carries a certain DNA and certain characteristics. So it's in the same way that if we can identify units that are repeatable in our facility, then by combining them, we can prepare composite intelligent planning units that then can be replicated n number of times in that particular facility. So that's really the concept of intelligent planning units. So IPUs can be implemented of course, in the real world. We can improve those through a refinement process. So if we adopt the intelligent planning unit philosophy, it's going to disrupt the industry. Now, instead of an architect designing a building from scratch, every other building from scratch, would perhaps be thinking in terms of what kind of intelligent planning units do I have that could be provided by different vendors that can be incorporated in my building, and I need n number of one type of IPU, and I need 5 of a different type of IPU. Of course, when we think in terms of product, in terms of modules, we know that we can improve those modules from process to process, from one model to the next model, to a third model. So that's really the process of improvement. As I mentioned, you can scale it from a nanoparticle level to a brick to a room to a building to a city, and to any level or any scale that you want. What I mean by that is an intelligent planning unit could be at a nanoscale, could be at a scale of a room, could be at the scale of a building, or it could be a scale at a campus. So these are all scalable concepts that can be implemented. And now with the help of IoT, we can actually integrate all of these modules that can talk to each other. For instance, if you have traffic sensors in different parts of the city, you can identify which part of the city is more congested during particular time of the day, and how you can reroute the traffic so that there is less congestion on the roads. Or you can monitor energy consumption on a campus in different buildings, and how that energy consumption could be minimized based on controlling from using IoT and using these IPU concept. So it's the scalability of IPUs that is the key, as I pointed out. An IPU is a well-defined planning unit with a very specific purpose and functions. It's applicable for physical entities, as I mentioned, as well as for process improvements. Allows replication, supports combination, is scalable, is modular, of course, in nature, and can be integrated in real time, and so on. So you can scale it, as I've been pointing out, from a nanoparticle level all the way to as much as you want to scale it. Of course, when it scales, it reduces the complexity of the built environment. It enables more intelligent planning, sustainability, and systematic interactions. And it also facilitates timely information for better decision making. So how would I define an intelligent planning unit? Well, it is that physical unit or process which has been optimized in design and purpose, perhaps with sensor technology as appropriate, and can be replicated and implemented at different levels of complexity. An IPU can be mutated. So if you look at just fenestration, for instance, if it is a south-facing wall or a north-facing wall, then you need different type of fenestration requirements, but that does not change the essential functioning of that IPU or intelligent planning unit as a fenestration. And you can mutate that to satisfy your particular requirements. Just like we buy iPhones, or we buy Android phones, or we buy automobiles. We have certain level of customization that is feasible. Though, as I mentioned, with Internet of Things, IPUs can be networked in real time, and we can gather information and data. And with the use of data analytics, we can have better control of these modules all throughout the environment. So again, scalability from nano level to as whatever scale you want to adopt. And as I mentioned, there are three phases of implementation, and one is the IPU application, replication, design. As I mentioned before, you can have each IPU would have a certain design signature, and when you combine these IPUs into form a composite IPU as per the requirements of your facility, then that allows you to plug and play different properties within your facility. Of course, all of this needs to start from a digital level, the planning and design process, the measurement process, collection of data, analytics, and then refinement. And once we have refined it on a virtual scale, then those models could be implemented easily in the real world. Just as an example, you could have an intelligent green space, intelligent central city, or residential city. These are the different color combinations here indicate different IPUs that have been implemented in different parts of the city that can be that can help you identify whether that is air quality, or whether that is congestion, or whether that is traffic modulation that you might require during specific times of the day, and so on. The various levels where IPUs can be implemented. As you can see, this is just a generic list. Intelligent processes, intelligent sensors and actuators, data analytics, intelligent planning, intelligent cities, intelligent buildings, and so on. In terms of intelligent planning, here are just a few examples. Elemental cost planning for project control, masonry work, traffic control, noise control, interior design, layout design, smart photovoltaic systems for fenestration, energy consumption, and so on. I mentioned that IPU concept could also be used for process improvement. So if you were to consider masonry as an example, and if you were to take a certain unit length of masonry within your project, let's say 10 meters of masonry, so you can easily identify how many masons you're going to need, how many laborers to support the mason, what type of material in terms of brick, pallets, mortar, etc. would be required, what type of scaffolding is required, what type of safety parameters are necessary, how can you optimize the cost of that process just for the 10-meter unit length that you might have selected. And once you have optimized based on all the key performance indicators that you can think about, you know that that is optimized for the 10 meters, and you have hundreds of those meters on your project. So you can easily replicate that unit, that intelligent planning unit, in terms of process within your organization and make it more optimal. We can easily keep track of how you are implementing this concept in terms of poor, very poor, regular. Depends on implementation of these IPUs as a philosophy for modular construction. And as you can see, once I mentioned about KPIs, those could be cost, schedule, quality, safety, sustainability, etc. And as you can see in this image, in your planning, you could be planning these multiple modules or multiple intelligent planning units. And as you can see from different colors, and as they go into the facility, high-rise building in this particular case, then you can see that how the thought process is different in terms of how many IPUs, what type of IPUs, how do I structure those IPUs, rather than thinking about that each facility is going to be different and needs to be designed from scratch. So just to put a seed of thought in your mind, so with that quick introduction to intelligent planning units and our results that we obtained from the CI research, let me conclude my presentation by saying that I was able to highlight the workforce needs of 2030, how we will be needing more offsite construction, more modular construction, and what type of workforce training would be required. So towards that, I presented the roadmap of offsite construction in terms of people, process, and technology, and introduce more advanced thought processes in terms of philosophy of intelligent planning units and how that is likely to disrupt the way that we presently think about each and every project, and how we can think about IPUs in the future and the thought process that would be required. I illustrated the application of IPUs for future cities and smart construction, and of course highlighted the modular concept, the application of IPU in design process and lean construction, and then the IPU philosophy, as I mentioned, is of course a paradigm shift that could play a major role in the modular construction industry. With that said, I want to thank all of you for your patience, and I would be more than happy to answer any questions. Thank you very much.
Thank you, Professor Hastak. Was amazing. I'm sure people have a lot of questions for you, and I'm inviting Ramon to lead this process of Q&A.
Thank you so much, Professor, for sharing all of your knowledge in that subject. It was very insightful for us. I think we have the habit of looking sometimes more at the problems of the traditional construction methods instead of looking inside of the offsite constructions on pains. And I found your maturity model approach to look inside the industry, and see how it can continuously improve and unlock its potential. So thank you so much. And I'll just talk a little bit in Portuguese to the guys here. Pessoal, vocês podem colocar as perguntas no chat, que eu repasso para o professor. Se alguém quiser falar diretamente, perguntar diretamente, pode só levantar a mão para a gente organizar as perguntas. Eu vou fazer uma primeira pergunta aqui, enquanto vocês podem, na medida que tiverem dúvidas, colocando no chat para a gente repassar aqui. I'd like to make the first question, Professor. In the recent years, we had a lot of evolution in the market, but also many conic projects fail both in US and UK. And they were major companies with abundant resources in terms of both technology, process, and even skilled people. To what do you attribute this phenomenon? Which key construction competencies that were mapped do you think that in general they were not following?
I think I mean that's a very good question, and we have presently one of my PhD students, actually two of my PhD students, are looking into exactly that problem, in terms of why do we find, and what our focus is more on mega projects, and you mentioned projects around the world that have failed. We are looking at some of the mega projects and the failures, and just to give you a preliminary indication. What we have found is that there's a scalability issue, that companies who are engaged in maybe, when we talk about mega projects, we are talking about $1 billion and more. And many of the companies that take on these projects, they have not done scaled projects of that scale. And they believe that, they might have done maybe $500 million of project. And they believe that, yes, they can easily scale to $1 billion and the management process is same. No, and what we are finding is that is a very wrong approach in terms of managing mega projects. What is perhaps more feasible is to think about a mega project as perhaps 10 different smaller projects, and manage each of these 10 projects as you would, of that scale, and then see how they can be integrated to make sure that the mega project is successful. So that research is still in progress, so I won't be able to give you more details, but that's what we are finding, that the failures are more because of scalability, that the companies think they can scale, but they're not able to.
Thank you so much. So kind of the IPU's philosophy could be the answers.
Yes, absolutely. Absolutely.
Professor Vanderlei John, do you want to make any questions?
Yeah, no, thank you very much, Mark. It was really very interesting. I think there are two major concepts that, for me, the one is maturity. Most of people think that embracing a new technology is an act of will, and you just decide and then you start making money. And what really your approach shows is it is a process, and I like it very much. Your timeline is 6 years, and I'm not really accustomed with construction. I don't do research in construction, but I know for sure that the building materials industry, if you want to put a new product in the market, it's something like 5-6 years to get it through the entire process from the beginning. So I think this is a real important concept, and maybe Ramon and Rubiani and Beda, we can really think on that kind of tool for assess the maturity of the companies, adapt to Brazil and perhaps to Chile as well, and because I think it's very useful. Do you think this kind of tool can be adapted, or it is kind of universal? What we could do this process, you know?
Yes, absolutely. I mean, the tool is universally applicable. What might be important in terms of making it more customizable to different countries might be looking at the different processes. I had shown list of processes that were being implemented or should be implemented in the US, because that was the primary focus of our research. But it can be more customized to add other innovative processes that might be available in different parts of the world and make it more customizable in that sense.
Well, I think if we find the resource, we are going to come back to you and ask for your help to adapt this to Latin America, perhaps. I think it will be a very interesting outcome.
Certainly, I'd be glad to help.
Thank you.
We have more questions here regarding the maturity model. Rubiani asked if there is a relationship between the maturity model and risk assessment of companies' business model.
Yes, indeed. As I was mentioning earlier, the entire maturity model is pointing at how immersed you are in adopting the philosophy of modular offsite construction. And the maturity model points out whether you have, as an organization, ingrained that philosophy, or are you still thinking about perhaps one module within that particular project or two modules within the project, and it's not really a modular philosophy that you've adopted, but more of just using a few modules within the construction process. So the maturity model indeed points out that if you are going to adopt the philosophy of offsite modular construction, then you really need to start as early as possible. You need to make sure that your organization, you have a champion within your organization that is going to drive the process, that the philosophy right from the concept stage is offsite and modular, because that is going to influence the risk that you have in terms of supply chain, in terms of lead time requirements, in terms of the workforce requirements that you might have, to make it a true plug and play type of a project, where as the modules get shipped to your site, that the site is ready, there are people that are trained to actually receive the modules and put them in place. So indeed, it is very much tied to your risk assessment model. I hope that answered the question.
I think so. We have another question from Danielle. Considering that modular construction in Brazil is beginning, we have a lot of steps to achieve a good position in this context. What do you think about this kind of construction in Brazil and Latin America, and what do you aim for in the near future?
I think that's a very good question, and as I pointed out, in putting my presentation together, on purpose I chose those two different things. One is what is the state of the industry and the maturity model and so on, and then a little bit of futuristic thought process of where we can go from here in terms of modular and offsite construction, and in presenting the intelligent planning unit concept. So clearly, the construction processes are different between Brazil and United States, for instance. I think, if I'm not wrong, and correct me if I'm wrong, that your construction is more concrete and block-based construction as opposed to wood frame construction, as we have more in the US. So in that regard, how we scale from a commercial level or a residential level to a high-rise level, the thought processes will have to be reconsidered in terms of modular capabilities are required, or what offsite capabilities are required in terms of manufacturing, in terms of training requirements. So those are the differences that I see, but the concept remains the same. The concept is more how do we think offsite and modular right from the conceptual planning stage of a project. The methods and techniques, of course, are going to vary from one part of the world to another part of the world.
Okay, thank you, Professor. Let's go to another one question. It's from Paulo Oliveira. Looking into the future and the projections of changes from Industry 4.0 to Industry 5.0, certainly it generates many new challenges and opportunities for offsite and modular construction. How can the IPU philosophy be more effective on this journey based on the transformations presented?
That's, again, very, very good question. So the IPU philosophy is based on identifying units that are repeatable in a particular facility. So from that point of view, we can think about human-centric planning processes. We can think about resilient planning processes, resilient design of units, and more, of course, from a sustainability point of view as well. So when you're thinking about an IPU concept, you can also think about future maintenance requirements in terms of if a module fails, you should be able to remove that module and replace it with another module. So that of course feature applies to whether it is just for maintenance or whether it is a post-disaster requirement that you're thinking in terms of a resilient rehabilitation concept for that particular facility. So again, within that, the modular industry can play a very strong role because in terms of IPUs, as I mentioned, like Model T cars, Model T, you can only get in black and nothing but black when it started, Ford started that. But now we have cars that you can buy in any different color, shape, and size, and so on. So, same thing with our mobile phones, for instance. So think of that in terms of IPUs, where your initial IPU would have a particular design and optimized for requirements of that point in time. But as time progresses, that same IPU can be improved. You can satisfy requirements of your client. If a client depends on whether they want a gold-plated IPU in terms of your sustainability goals or your cost-saving goals, or whether they want a cheaper version of that same module, that can be done as well. So the IPU concept is very much applicable in terms of Industry 5.0 concepts that I mentioned earlier about sustainability, resilience, and then human-centric in terms of process, in terms of how the facility and the unit can be planned in itself.
Perfect. And continuing on that subject of the IPUs, I'd like to know if is the concept of IPU related to or inspired in other manufacturing methodologies and philosophies, such as the lean approach of reducing batch sizes, modular coordination, and product platforms approach?
Absolutely, absolutely. That is the essence of the IPU concept, because what you're trying to identify is that first of all, if you think, if I didn't show you that figure, but if you think like this, that you are scaling from a small IPU to a bigger IPU, like a room to a building to a block or whatever. So you can define at what level you want to define your IPU. Your IPU could be a brick, or you might say, no, I want IPU at the level of a room, for instance, because that room is getting replicated n number of times. And how I can optimize that room in terms of my construction process, manufacturing process, sustainability concepts. So of course, all the lean principles that get implemented. And as soon as you say you're refining that unit, you're thinking in terms of manufacturing. You're thinking in terms of the production process. So it could be a small batch production, depending on what type of facility you have, or it could be a large batch production. Again, depending on what level of module you decide and you decide to design for that. So all these concepts are very much implemented within the IPU thought process.
Thank you so much, Professor. I think we are running out of time. So, Rubiane, don't know if you want to make any final considerations.
No, I just want to say thank you again. That was very enlightening. I guess we have a lot of food for thoughts now, as Wanderlei said. Probably we're gonna knock your door again and maybe ask some more questions in the future. Thank you again for your presence, for everybody that could be with us today. And after now we're gonna have a small meeting for the team, so it's gonna be in Portuguese. That's why I'm not asking you to stay, but I'm sure you have a lot of things to do today as well. So Wanderlei, any final thoughts?
Well, Mark, thank you very much for your time. I love the IPU concept. I think it's modular concept going to all directions I think it's a kind of vision that I was expecting from you, and that's congratulations for your job. Thank you for your time.
My pleasure. Thank you indeed for inviting me, and I hope you found my presentation to be value-adding. So thank you very much.
Thank you very much.
Thank you.
Thank you.
Bye.
Bye.
Bye-bye. Thank you very much, Professor.